Okay, so I'm Yaniv, I'm CEO of Panoply, and today we'll be talking about preparing your data stack for growth. We'll talk about the data stack, the data lifecycle, what growth really is, and then touch about the modern data stack, its components, and what to think of when building it and beyond. So here's the truth. The truth is that no one in the organization really cares about your data stack. No one cares about how cool the technology is or how fast something does this or that. No one really cares because the data stack is not a goal. The data stack basically just needs to work and needs to enable the organization to provide information. What the organization really cares about is information. And a modern organization going through the digitalization of its data has many different sources of data. Many sources of analytical information and different storage technologies. There are several challenges when it comes to storing and accessing data. These challenges depend on your company, your vertical, your position in the organization, and many other factors. And what we're going to focus on today is specifically the challenge with analytical data. Data that is prepped and analyzed for internal decision-making processes. The process of taking siloed data or siloed application data from multiple data sources and turning it into actionable information. This is what we call the data lifecycle, and it's an output of the data stack you're going to build. When looking at the number of SaaS applications per company, the number grows exponentially as the company grows. And making sense out of this mess becomes more and more challenging. For example, a mid-market company between 100,000 employees uses about 185 applications, while an enterprise company over 1,000 employees uses about 288 applications. These numbers seem reasonable, but when you consider the app-to-person relationship connections, the number expands greatly. It goes from thousands, 4,000 to 20,000, depending on the size of your organization, and it grows and grows and grows. It becomes a huge mess to build and manage for a small team of users. With all these business use cases and different verticals, making sense of data becomes extremely complicated, and as the company grows, making sense of data becomes slower and more expensive. Data remains siloed in specific applications, and customer experience suffers. In fact, Gartner stated in a 2020 report that technology sprawl is one of the 10 business challenges faced by business organizations today, and unless managed carefully, the tech stack sprawl can be incredibly debilitating for an organization. The key here is defining the correct processes and technologies that enable agility and flexibility so that people, processes, and technology don't slow you down as the company grows. And when choosing the wrong solutions or building manual processes in-house, the scalability of the processes get challenged due to many internal technology and personal interdependencies. When a medium-sized company is reliant on a number of data engineers to manage all of what we see here, hundreds of ETL processes, resources allocation of different storage technologies, optimization of different schemas for performance, and managed connectivity of hundreds of applications and a number of third-party tools, these are bound to slow you down no matter how good they are. An in-house team and process is almost unscalable by design. A good process starts really with a good definition. So let's try to define the data lifecycle. Really what the company is looking for, really what needs to happen in order to provide the organization information. So very generally speaking, the data lifecycle is divided into three categories of challenges. These are technical and process challenges and people challenges. But basically three categories of challenges: data ingestion, data storage, and data accessibility. These three families of challenges are interdependent when it comes to building a successful data lifecycle. The three categories, which we will dig into deeper a bit later, encompass universes of people, technology, and processes, as we said before, that all need to be synced and managed for a successful, scalable process. So really, when we talk about setting your data stack for growth, we're talking about the ability to sync people, technology, and processes across these three families of challenges, building your data stack to serve the data lifecycle. Growth. The core goal of your data stack is information. It's enabling the data lifecycle to run smoothly. It seems obvious, but it's not. Because most companies today, most people today, still think of the data lifecycle and see the data stack. All engineers obsess on how fast, efficient technologies work. All business users obsess about the information they get to optimize their product, their sales, their marketing processes. It's a major difference. The core distinction between building your data stack correctly for growth or correctly for engineers. A data stack built for growth is a data stack obsessed about the information output that comes out at the end of that pipeline, at the end of that stack. This is where things become challenging. When we look at building our data stack and ask how the data lifecycle will work on top of it to benefit the business users, we need to ask, who are the people that we're serving? Every vertical, every business use case, every business unit is different in the information they need to access and in their ability to manage analytics and ask analytical questions. There's a monumental difference between a sales rep, a CTO, a data engineer, in terms of the sources of data that they need to ingest in order to access their information, the schema they need to build, the questions they ask, and the speed and iterations they need in accessing information. The data stack needs to be agile enough to serve a data lifecycle that is different for different stakeholders in the organization, but it also needs to be rigid and robust enough to serve as a central source of truth for the entire organization. So who are you? When looking at the data stack you're building today, ask yourself, who are you and what do you want to be? Who am I now and where will I grow to be? Are you a retail company focused on brick and mortar stores? Are you a sales-obsessed e-commerce organization? Are you a research unit in big pharma? Who are you and where do you want to be 2, 5, and 10 years from now? The modern stack. So the modern stack, really a couple of small things or a couple of small bullet points that will guide you to build your modern stack. The most common mistake any growth company can do today is think that they need to build their own data stack from scratch. If you have a data engineer right in your company right now writing ETL processes, then you're making a mistake. If you have a head of BI telling you that your challenges are so unique, you need to build your own dashboards or run your own processes, you're making a mistake. And if you have any data stored on-prem, not because of regulatory issues, you're making a mistake. Because all the processes, all the technologies you're going to build are going to be unscalable by design. And when I say mistake, I don't challenge the technologies or the people or their virtues. I mean, you're probably paying too much money and your company is too slow in getting data to information. And your stack, as mentioned before, by design is not scalable. There are fantastic off-the-shelf solutions to manage your data ingestion processes. There are fantastic cloud storages that are more or less flexible with resource management, and for specific use cases like marketing analytics, there are specific end-to-end infrastructure technologies that manage the entire processes for you. These companies have spent millions of dollars and have seen thousands of use cases to serve your specific needs. There's nothing you can build internally that these companies have not thought of to serve the technology needs of your data stack. Therefore, I think the question in building your data stack is not how to build it, it's which off-the-shelf solutions would be best to integrate into your infrastructure in order to best serve the data lifecycle for your specific use cases today and for the future use cases 2 and 5 years from now. Let's take a closer look, looking at thinking and storage and management and accessibility. Let's take a closer look at what questions you should ask when assessing these technologies. So when looking at data ingestion is really one of the core pillars of the data stack. If you got data ingestion wrong, you're probably going to get the whole stack screwed up, and you're going to pay for it later on. So really, when you look at data ingestion technologies, you should be asking yourself 5 questions. Looking at the amount of data sources, the completeness of data sources, the simplicity of integration, the price and performance of these sources. You should be asking yourself, does the integration solutions that I'm looking at, do they have all the data sources that I need to serve and answer my business questions? And if they don't, do they have the flexibility for me to add my own data sources? Or does this company have the flexibility to build data sources based on my demand? Does the integration solution easily connect to other integration solutions to provide maximum flexibility in the future? Because this specific company may be building out 30, 40 data sources and stop. I'm going to have to use another integration solution to get the other data sources. They might not have all of the data sources I'm going to need for the future. You need to look at the complete access to all API data. See that the data sources that they build really have completeness of data and not just small pieces of the API. They need to be able to ingest different data types. You need to look at how does the data ingest into the storage. Do they have capabilities? Do they have capabilities to manage semi-structured data and turn that into structured data? Different storages store data differently, and data may be parsed differently. How easy it is to implement the ETL solution. You don't want to be dependent on data engineers. You don't want data engineers to overwork themselves when looking at when working on and managing these solutions. So, do I need data engineers? Can analysts do it by themselves? How easy is it to monitor and process, and how simple it is to understand when things go good or things go wrong? How challenging is it to fix things if things do go wrong, and will they let me know? Do I need to go through their customer support, or can I just change things by myself? These are all questions that seem typical, but not all ingestion solutions are created equal. Some serve better and some less. Then, looking at pricing competitivity, you need to ask yourself how much am I going to pay now and how much am I going to pay at scale? Not necessarily against building the processes in-house, because building in-house will always be more expensive in the long run. Don't even ask that question. You should be comparing the pricing from one solution to another and looking at it not only now but also at scale. A lot of these integration solutions will be looking at pricing by compute, pricing by rows ingested, pricing by rows extracted. These all have small differences that may end up costing you a lot of money at the end. And then lastly, performance. Make sure that the speed of ingestion is fast enough for you to serve your business needs. Looking at storing and managing data, really four bullet points we need to focus on. So price, of course, is a huge element. Price is not necessarily the lowest price per gigabyte stored or per compute unit. Price is highly based on how you actually use your data. So you really need to look at your business use cases and think which storage technology will be best for me. Price is based on how you store the data, how you use the data, how you query the data. Different schemas can result in different costs. Different query types can and different query types and different BI tools can result in different costs. Because they all query differently, they utilize resources differently, and you really need to understand how you're going to use the data. Are you going to be querying on a daily basis, on an hourly basis? Do you need real-time data? Do you have a lot of historical data that they need to store, but you're only querying a small piece of the puzzle? So you really need to look at the entire puzzle and see what scale looks like for you in terms of your utilization of that storage component. Performance. Some storage technologies have different flexibilities in managing resources. Not all companies need this. If you store a lot, but query a small amount of data, then compute costs may not matter for you, but storage costs may. If you query real-time data, or even hourly or massively, and you have really huge queries, then compute costs can easily become very, very expensive. When looking at accessibility, optimization of schema, data types, and logic requires expertise. Some storage technology require more strict knowledge and definitions in order to make BI queries efficient. There's often a trade-off between paying for engineers' headcounts to optimize schema and storage and paying for compute brute force to return queries in a timely manner. And lastly, management. How flexible can you manage your resources? How flexible can I permit people, groups, to access tables in the database? So the governance capabilities. The last pillar, looking at accessibility of the data. Really three bullet points that we need to look at. One, how dependent am I on the underlying schema? How dependent am I the business user, the analysts, on the data engineer's sprints in order to do my job? How flexible am I in managing these resources? Can I do it without them? How dependent am I on IT data engineering teams to have my queries perform? And how fast are the edge cases being taken care of? Questions like how easily I can manage, share, and collaborate information around the data stored and siloed in the central repository. So kind of summarizing the data stack, looking at these three pillars, the bottom line is don't build it yourself. It may seem like a good idea in the beginning, but it's not. It's not going to scale. It just won't make sense, not from a price perspective, not from a speed perspective, not from a scalability perspective. Your modern data stack should consist of off-the-shelf solutions which your engineers will choose from a mix of best-of-breed solutions. And the thing is that really when you look at like these solutions that I have here on the slides, probably every mix of these best-of-breed technologies will serve your technological needs. Every one of them will be okay. So you won't get stuck with processes that look like this anymore. They'll be much more managed, and you'll end up paying less. They're going to look closer to something like this. But there's still one thing that's not scalable and will probably not be scalable about this modern data stack that you'll run to at scale. The technologies we looked at are good. They're good enough to make sure that your technology is scalable. They're good enough to make sure that the stack is scalable, but they're not good enough to make sure that your data lifecycle is scalable, the process itself. And that's because of these interdependencies between different technologies. Because it's a data stack that's built for engineers. The interdependency between technology and people is still there. The engineers are still the ones that are connecting the wires and making sure that technologies address each other properly so that the analysts, who are the true customers of the data lifecycle, can get their information. Which means that the analysts are still dependent on the data engineers to do their job properly in order to access information. Which means the business users that are dependent on the analysts are dependent on the engineering sprints in order to access their information. At Panoply, we see the evolution of the modern data stack going from an engineering-centric process to an analyst-led process, putting the management of the entire data lifecycle in the hands of the analysts and letting the engineers focus on more business-oriented tasks rather than managing ETL processes. And that's why the Panoply platform focuses on no-code, automation, and business-ready data, and really analyst and business user-centric focused as opposed to engineering-focused. When a business user or SQL analyst utilizes the Panoply stack, they get the ability to manage the entire data lifecycle, not the data stack. The SQL-oriented analysts can ingest data through an automated data pipeline with no-code interface, which enriches and augments the data and creates a default schema inside a serverless storage. They can then observe and monitor the schema and change whatever they want, or jump directly to one of the BI tools pre-connected to Panoply, push a couple of buttons, and their predefined dashboards based on the data sources that they have just connected are already showing them information. And once that's all done, in a process of approximately 4 minutes, the analyst, business user can go back, change, augment whatever they want inside the platform. But they go from a point of data to information of the entire data lifecycle managed by automation algorithms in about 4 minutes. So that's it. I hope you enjoyed the presentation, and I'm happy to take any questions.